So let's use football as an example. Teams play at their home venue, that means at home, and also play at other teams' venue, that means away. So suppose we consider the home and away performance of football club Southampton, okay? The information regarding the total number of home play and away, home is H1, away means H0. Suppose win, then it will get 2 marks, and then draw means 1 marks, and lose means no marks, okay? Suppose we have the following information, okay? 12 home win, 2 home draw, 5 home lose, 9 away win, 8 away draw, and 2 away loss. Then we can have this table. 12 home win, so win is here, home is here, so this is 12, okay? 2 away is here, away loss, so it will be this 2. 5 home loss, so home is the second row, loss is the first column, so it will be this 5, okay? So in other words, you can use a table to write down all this number. Here's the thing. Is this table a probability table? No. Because probability axiom number 2, the probability of the sample space is 1. What's the probability of sample space here? The probability of sample space is all the boxes added together, but you can see that if I add all this number, it's not 1. So you need to normalize it. So what's the normalization? Suppose I want to consider the marginal probability of Southampton to win a game, regardless of whether or not it's playing home or away. So I want to know the win regardless of home or away. That means on the y dimension, I don't care about y dimension. I add these two numbers, so 9 plus 12, 9 plus 12, this is the number of win, and then divide by all the number of the matches. This will make sure the P is a number between 0 and 1 that satisfies the probability axiom, and this gives us 21 divided by 38. That means in the 38 games, 21 games is win, regardless home or away. What's the conditional probability that Southampton will win given that they already play at home? So that means win given that play at home. So again, condition is what? Joint divided by marginal. So what's the joint? The joint probability will be R2H1. So R2H1, this 12. Okay, but this is not probability. We have to divide everything by the sum. So it will be 12 divided by the sum. So it's 12 divided by 38. And then this is the joint. What's the conditional? Conditional is home. We don't care about the column. We only care about the last row. It will be 5 plus 2 plus 12. Again, 5 plus 2 plus 12 divided by all again. That is 38. Then we have this. It will be 12 divided by 19. What's the conditional probability of Southampton will win a game given that they are playing away? Okay, so we want win given that away. So win given away. We have already know that the win given home. So by complementary rule, we can just use 1 subtract this number. So that will be 7 over 19. You don't need to compute this big chunk of thing by looking at the table. This is showing that you can have shortcuts. Do you believe that Southampton is more likely to win at home when they are playing away? So basically it is comparing whether or not the win rate given that at home versus the win rate given that they are away. So the win rate at home is 12 over 19. The win rate when away is 7 over 19. So win rate at home is bigger. So this is true. So now here is a very complicated probability. So suppose Southampton will play an away game, then a home game, then an away game in the next 3 match. What's the probability that they will not lose 2 out of the 3 games? Not of lose 2 out of the 3 is the same as lose 1, win 2, or win all 3. This one have 3 possibility. That's the 3 possibility here. And then lastly, this win all 3 game is basically means win, win, win. So that means we need to compute the probability of lose, win, win. So this is lose, win, win. And then win, lose, win. So win, lose, win. And then win, win, lose. So win, win, lose. And lastly, win, win, win. Win, win, win. And don't forget, the first game is play away, then home, then away. So away, home, away. Away, home, away. Away, home, away. Away, home, away. So that means what? You need to compute a big chunk of probability. Let me just do the first one. R equals 0. H equals 0. So it will be the joint of R0, H0. That means 2 divided by the marginal of H0. H0 means I only look at this row. So it will be 2 divided by all again. Divide by 2 plus 8 plus 9. So this thing. And normalize by 38. So this is the first number for this part. And then you repeat all the other number in a similar way. It will give you this very big chunk of sum, which gives you 26% chance. So you can use this to predict what is the result of Team Southampton not lose 2 out of 3 games.